Hey everyone, how are you? Welcome to the Python modules playlist, and in this playlist we try to understand different Python modules, one module in one video. In this video we are going to explore the Python's math module, which can give us an extra mathematical power beyond Python's basic operators. So whether you want to get the value of a square roots, perform some trigonometry functionalities, use some math constants like pi, or maybe perform some logarithmic operations, everything is being covered by this math module of Python. So I have a program of Python created named as math_module.py. In this program, we will cover every important aspect of the math module of Python. First of all, to use the math module, we need to import the math module, and we can say import math. This is how we import the math module. First, let us try to explore the constants which are there in maths and what are the different constants which are available in the math module. So we have the pi, which is equal to 3.14 something, right? So you can say math.pi. This is how you can access the value of pi. You know about a term called as e in maths, right? This can be accessed by math.e, and there is something called as a tau, which is double of math.pi. You can say 2 multiplied by math.pi, or I can say 2 multiplied by pi, or I can directly use the constant provided by the math module called as tau, math.tau. So these are the three important mathematical constants which you should know, and you can have these available in the math module of Python. Let's print the values of these variables and let's run the code and let us see what's the output we are getting. So I can say python 3 math module.py, and you can see the value of pi is 3.1415 something, right? The value of e is around 2.71, and the value of tau is exactly double of pi, which is 6.28 something. Now let's go and let's focus on the rounding functions, how to round out some numbers. For example, if I have 4.5, I may want to round this number to 5. That is, I want the upper bound of 4, the next integer which is more than this. Or I may want the next integer which is less than 4.5, which is 4. Or sometimes I just want to remove this decimal, right? I may want that, okay, if I have a number, let us say 3.5, I just want to remove the decimal and it will become 3. So how to do these functionalities? Let's try to understand this. So this will come under the rounding functions. First of all, let's see how to get the upper bound of a number. So let us say I have a number num which is equal to 4.5. I can say print math.ceil function. This function is going to get me the upper bound or the next integer which is more than 4.5. So let me pass this num here. If I want to get the next integer which is less than 4.5, the function name is math.floor. You can pass your integer, and this is how you can get the floor of this value 4.5. If I just want to remove this decimal, what we can do is we can say print math.trunc. Trunc. In this you can pass the value of num. Let's now run this and let us see the outputs. So let me first clear the console, and now let me run this. So now you can see the output for math.ceil is 5, the output for math.floor is 4, and the output for math.trunc is 4. Now you might have a doubt that why do we need this trunc function if I have the floor? Because floor is doing the same thing, right? It is just removing this decimal and it is giving me the output as 4. But that's not exactly what's happening. For positive numbers, these functions are going to behave the same. But for negative numbers, let us see what the output is. Let us say the number is negative 4.5. Can you guess the output? Try to pause the video and try to guess the output. Alright, have you guessed it? Let's now run the code and let us see what is the output. For math.ceil, it is minus 4. So now you will see that this is converted to minus 4 because the next integer which is more than minus 4.5 is minus 4, right? But the next integer which is less than minus 4.5 is minus 5. So the output for math.floor is minus 5. But for math.trunc, it is not minus 5. It is not behaving like math.floor. It is behaving like math.ceil for negative numbers. So basically try to understand the functionality of each function one at a time. Ceil is going to give you the next integer which is more than your number. Floor is going to give you the next integer which is less than your number, and truncate is simply removing your decimal points. So you can see the output is minus 4. Now let us see what is the output for minus 4.0. If I just print for this one, you will see the output for all the three scenarios are minus 4. So basically if it is an exact integral value, then it is going to return you the same number. It is not going to increase or decrease anything. So you will have to understand it. If it is a decimal point number, you will get to see the next number. If it is the exact number which and the decimal points are 0.0, then nothing is going to happen. It is just going to return you the integer. So now that we are clear with the rounding function, let's go on to understand the power and roots. For example, if I want to find out what is 3 is to power 4. So in Python we have a way. We can say 3 double multiply 4. Basically here what we are saying is I want to find the value of 3 is to power 4. If I print this, you will see that it is 81. 3 to power 4 is 81. But how can you do it using math module? So we can say math.pwo power. In this you need to pass two arguments. The first argument is the number to whom you want to raise the power to. So it is 3. And what the power you want to raise it to? It will be 4. So here we are trying to find out 3 is to power 4 using the math function. And now if I try to print it, you will see the value is exactly the same, but this time it is in decimal. It is a float number. Earlier, when we tried to find out the power using 3 to the power 4 using this particular operator, the double multiply operator, it is giving me the output as an integer. But math.power will always return the output as a floating number. Now there is another PWO power function, and let me try to show you that. Print, I can directly say POW power, and I can pass 3 comma 4, and once I print and once we run the program, you will see the output is 81 and 81.0. This 81.0 is coming from the power function of math, and this power function is a built-in function which is already imported in your Python program. You don't need to import it, it is already imported because this is a built-in function. Now if I try to pass 3 comma 4.5, you will see the output in decimal. You can see the output is in decimal, but if I pass it as 3 comma 4, you will see the output is integer. But that's not the main power of this particular built-in power function. There is one important functionality provided by this built-in power function, which is not available in the math.power function. Let me show you that we can pass a third argument in this function, and can you guess the output? The output is 1. Basically what happens is, this is actually converted to a statement called as 3 double multiply 4, which is like 3 to power 4 mod 10. So if you want to find out the value of 3 to power 4 mod 10, that is you want to calculate the power and also mod it with some number, then you can use the built-in power function, which is more powerful than the math.power function. But yeah, this is the built-in power function. This is not available in the math module, but it is available in a Python program as a built-in function. Now let us see another function. Can you find out the square root of 16? So I can say print math.sqrt, and I can pass the argument as 16, right? This is going to return 4. So this is how you can find a square root of a number. But as a trick, I will tell you, you can also find the square root of a number using power function. You can say print math.power. Let's find the power of 16, but we are going to pass the argument as 1 divided by 2. Let us see what is the output. The output is 4. So you can use this trick to find the square root of a number. And why is this useful? The reason is now you can find the cube root of a number as well. You can pass 1 divided by 3. And if you print it, you will find that you get an output. And if you take the cube of this particular number, it will be equal to 16. Let us do it for 27. What is the cube root of 27? It is 3, right? If you print it, you will get the value as 3. So this is the trick you can use to find out the square root, the power, the cube root of numbers using the math module. Now let us work on factorials and GCD, that is greatest common divisor. How can you find the factorial of a number or greatest common divisor of numbers? Let's try to find out. So I can say print math.factorial of 5. What is the factorial of 5? It is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, right? So you can use this function to find out the value. Let's try to print it. If you will print it, you will get the output as 120, which is the exact factorial of 5. If you want to find out the GCD, that is the greatest common divisor of two numbers, you can say math.gcd and pass those two numbers. Let us say we want to find out for 48 and 18. I think the output has to be 6 because 6 is the highest number which is dividing both the numbers. So let us see what's the output. So let me run the code. So the output is 6, right? So the GCD or the greatest common divisor of 48 and 18 is 6. Now let us see the next functionality, which is trigonometry. If you are working on trigonometries or if you are working on any scientific computation, you might be knowing about trigonometries, right? In trigonometries, you might have heard about sine, cos, tan, cosec. All these terms are trigonometric terms, right? Basically, these are mathematical concepts specifically for trigonometry. If you want to find out the sine of a number, math.sine of 90 degree, then this is not the way. I will tell you the way, but yeah, the function is sine, .sin sine. Let me clear the console, and when I will print it, you will see the value is 0.89 something. But if you are somebody who is working on trigonometry, you know that the sine of 90 is 1, right? Basically, it is expecting the radian and not the degree. All those people who know about trigonometry, they will be able to understand that what is the radian and what is the degree, right? So right now we are trying to find out the sine of 90 degree, but in the sine function, we need to pass the radian. So you need to convert your degree into radian. So you can say math.radians, and in this you can pass your degree. So now what will happen? First of all, your 90 degree is converted into radians, and now you are passing that radian value to math.sine. Now if you try to print it, the value will be 1. So math.9 of 90 degree is 1. Similarly, let me copy this code and let me try to find out math.cos, or basically the cos of a degree or tan of a degree, right? So I can say math.cos, I can pass 90 again, I can say math.tan, and let us pass the degree for cos as 0 because because cos of 0 degree is 1 and tan of 45 degree is 1, right? And now if I run the code, you will see that the value is 1, 1 and 0.99999 something, right? So you are getting your exact values, but for math.tan, it should have been 1. It is not 1. I will tell you the reason for this. What happens is in programming and not specifically in Python, there is a small error for floating point numbers. So this is that error. The error is very less. It is around 0.000001. But if you have an error, you will want to fix that error, right? In the math module, there is something called as math.isClose. So I want to find out, is my output, whatever is my tan value, is it close to 1 or not? So I can say tan value is equal to this particular value which we have just calculated. Now math.isClose, I want to say that is this particular value, the tan value, is this close to the ceiling, the math.ceil of tan. So what we are basically doing is we are trying to find out, is this tan the math.ceiling of tan? Basically this is 0.999 something, right? And now this is 1. This should have been 1, but this is very close to 1. So this isClose function is going to calculate how much close are these two numbers. And I want to find out, are they close enough that the error between them is very, very less? So you will have to decide what should be the error which is acceptable. So we need to pass the acceptable error in rel underscore 2l, and this will be equal to, let us say 0.000001, right? Now we can also pass this as 1e minus 9, 0.8 times 0 and then 1. And now let us print this value. Let us print and let us see, are they very close enough or not? And now before actually running the code, let me remove this print statement, because now we are not trying to print the value of tan. We are trying to check if this tan is very close enough to be considered as 1 and not 0.999 something, right? So now let me run the code and you will see the output is true. So from here we can understand that this is actually equal to 1 and not 0.99. We can replace this with 1 and check the same thing. You will see the output as true. But if you want to find out the radian for 44, not 45 degree, you will see the output is false, because now they're not close enough. But if you reduce the level of error, that is, let us say you are saying that an error of 0.01 is acceptable. And now if you try to print it, you are still seeing false. Okay, let me try to print the value of tan. If you print the value of tan, we can see that this is 0.96. Okay, let us say error of 0.1 is acceptable. Now if you try to print it, you will see true. So here we are trying to say this 0.96 can be considered as 1 because the acceptable error is 0.1. So this is how you can utilize these functionalities of math module, the isClose function, to avoid the floating point issues, which are not there specifically in Python. It is there in a lot of different programming languages. Now let us try to understand the last part of the math module, which is the logarithmic functions. How can you perform the logarithmic task? So let us say I want to find out the log of 100 to the base of 10. So I can say print math.log 100 comma 10. If I print this value, you will see the output as 2, because 10 is to power 2 is equal to 100. That is what basically log is all about, right? But if I remove this 10, that is, if I don't pass any base, I just want to find out the log of the number 100. By default, it will try to find out the log of the number with the base as e, this math.e, which is approximately equal to 2.71. If I try to print this, you will see the output is 4.605 something. If I just pass comma e, which we have calculated earlier as math.e, you will still see the output is same. So that is what math.log function does. You can pass the argument as 2, argument as 10, but for base 10 and base 2, we have specific functions like math.log2 of 256. That is, we want to find out the log of 256 with the base of 2. So let me put it here in the function, in the first function as well, and let's run the code, and you will see the output are same. Basically, we are doing the same thing. Or if I want to find out the log of 100 with the base 10, I can use the function log10. This is the function which does the same thing. It tries to find out the log of 100 or log of whatever number you pass with the base 10. So if I try to print it, the output for this and this is same, right? It is 2 and 2. So this is all about different functionalities available in the math module of Python. Let's create a small mini project. Let us try to find out the area of a circle. So let us say radius is equal to something which we are going to get as an input. So let us get an input, enter the radius of the circle. Let's convert it to float because the radius can be in decimal. The area is pi r square, right? R is the radius. So I can say pi multiplied by math.power, pw power function, pass the radius and pass the power as 2. And now let us print the area. So we can say area is plus area, right? Now let me run the code. It will ask you an input, enter the radius of the circle. Let us say the radius is 4.5. Hit enter. Okay, so we are getting an error because we are trying to concatenate a string and a float. So let's convert this float to a string. And now let's again run the code. Let's pass the radius as 4.5. You will see the area is 63.61. If you run it again and let's pass the radius as 2, you will see the area is 12.566. So this is a kind of mini project or something which you can do using the maths module of Python. So that's the math module in Python, guys. In the next video of Python's module playlist, we are going to explore the random module to create unpredictable and fun programs. So that's it for this video, guys. If this video helps you to understand about the math module, then make sure that you hit that like button and don't forget to subscribe. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.